Hello students, welcome back. Previously we went through the factorization method of quadratic equations. Now the second method we have to learn is the square root method, and this is rather special. It doesn't apply for all kind of quadratic equations in general. In a special case when b is 0, then this part just drops out and we have ax squared plus e equal to 0 so that it can be solved x squared equal to p like this, and then we can take plus or minus square root. Here's an example, and it turned out I didn't bother writing an example because it's rather trivial. Okay, alright, let me create an example. Two x squared minus 9 is equal to 0. Okay, that's as good as any. Let's solve it. Flip this negative 9 to the other side to solve for x squared. 2x squared is equal to 9. And here, divide each by 2, then this 2 will be gone, and you're going to get 9/2. Alright, we got x squared equals to p form. Let's take square root of both sides. X is equal to plus or minus square root of p, but the right hand side is 9/2. So let's copy and paste that, and there goes the full solution. Now this is enough for me, but in case your grader may want a little bit more, especially if you're dealing with my math level web assign, which is computer grader which is following some stupid program. In that case, it may count this wrong because it's not completely simplified. In that case, you'll have to do this. You see, 9 is a square number, so square root of 9 is 3. So you can rewrite this thing as square root of plus or minus 3 over square root of 2, like this. This is better, but it can be simplified even further as a matter of fact, because denominator is irrational. Denominator is irrational, excuse me, so let's rationalize it by multiplying by square root of 2 to both numerator and denominator. And if I do that, denominator is square root of 2 times square root of 2, so it's just 2. So there goes the most simplified form. But this kind of manipulation is not required for me. If I'm grading, then I'll take this as full credit, fully sufficient answer. These kind of simplifications are there in case you may have to satisfy some other grader, maybe machine grader. Okay, so much for square root method. Now, quadratic formula method. This one works for all quadratic equations. Ax squared plus bx plus c equals to 0. Then x is negative b plus or minus square root of b squared minus 4ac over 2a. Everybody must memorize this formula. How to use it? Well, here's an example problem, and let's go ahead and use this one here. Alright, x is equal to, well, here's a quadratic equation, quadratic formula, and let's expand the font here so that you can read better. Okay, alright. What's b? That's negative 6. What's a? That's 1. What's c? That's plus 4. So let's do all this computation. B is negative 6, and this one here, negative 6, and a is 1, and c is positive 4. A is 1 here. There you go. Did I substitute everything correctly? Alright, now you can either punch it out into calculator, or if you want to do a little bit more precisely, okay, here is the simplification. Negative, so we have positive 6, and this one 2 times 1 is so just 2. Now 6 squared is 36, positive 36, because any square is positive. And 4 times 1 times 4, that's 16. All right. 36 minus 16, so that's 20. Okay, that looks good, but it can be simplified further, as a matter of fact. Yeah, this is not really necessary because it's intermediate. Now from here, no, let's just keep that. And then let's just continue in the next line. Okay, 20 is 4 times 5, isn't it? And that 4 is a square number, so it can come outside of this square root. Square root of 4 is 2. So 2 times square root of 5. Okay, we're almost there. And divide both by 2, we get 3 plus or minus of square root of 5. In other words, x is 3 plus square root of 5, or x is 3 minus square root of 5. Okay, there you go. This is quadratic equation, second degree, so we need two solutions. Plus square root, minus square root. This formula applies for all quadratic equations. So even if you can do this by factorization, if you cannot factor, or something is not really working out, or if you want to really check your answer, you can put everything into this quadratic formula and work it out. Okay, there's one problem, and how about the next problem here? Well, pretty much the same, except here we have non-integer coefficients, so the traditional factorization method will not apply at all. We're going to need the quadratic formula, so let's come back, copy and paste this thing, and then let's do this. By the way, this must be coming from some modeling problem, so nothing is accurate. Let's expand the font. So let's use approximate equality sign. So 2.725 must be approximate value. 8.643, 4.195, all these must be some approximate values. And then put all those into this quadratic formula, and then let's run calculator. So in place of b, you have to put negative 8.643, and over there as well, negative 8.6643, square that thing. And then in place of a, I have to put in 2.725, here as well, 2.725, and then in place of c, negative 4.195. Please check. Did I put in everything correctly? Even bigger font, maybe. Oh, that's too much. Okay, about that. And then let's run calculator. Pick up your calculator and then calculate it out. Here, let me use Mathematica for that. And Mathematica will not understand plus or minus. It can write like this, but as far as computation is concerned, I have to specify so that it can calculate. So plus square root, minus square root, we get those two solutions. So in other words, t is approximately equal to 3.599 something, which is about 3.60. Okay. Or t is approximately equal to, yeah, this one, 0.427 something, and that's, oh, negative 0.43, approximately speaking. Anyway, here are the solutions. The problem did not specify how many decimals this to take, so and it doesn't matter how you simplify. Maybe you should not. Anyway, like this. By the way, if this kind of problem appears in modeling problems, such as some business problem or geometry problems or some physics or chemistry problem, whatever, in many cases, you may have to discuss a negative t-value and take the positive t-value only. For example, if you have to produce negative number of some quantity of some product, whatever, or you have to take negative amount of some substance, or area or volume becomes negative, whatever, don't make much sense. So positive answer may be the only right answer, but in some other cases we may have to look at both, case by case, especially for modeling problem that came from, real number application. Okay, so much for the quadratic formula method. And that'll do it for the theory part. Let's meet again with a little bit more complicated problems and applications in a third video.